Hello everyone, welcome to Patan's chemistry class. This is my YouTube channel. You can find educational videos here. Today we are going to solve rotational spectrum numerical, which is a topic related to the BSc third year semester 5 students. Topic is spectroscopy. Myself A.K. Patan, Department of Chemistry. Others Education Societies, Arts, Commerce and Science College, Ingoli. So today's numerical is based on rotational spectroscopy. Numerical is the pure rotational spectrum of the gaseous molecule CN consisted of series of equally spaced lines separated by 3.82 per centimeter. Calculate bond length of the molecule. Given mu reduced mass 1.0 into 10 to the power minus 26 kilograms. For that we have to go for first given data. If you read this numerical, you find that the spectrum is consisted of equally spaced lines, and each separating line is separated by distance 2b, where b is rotational constant. So b can be calculated, can be found from 2b, and here 2b is equals to 3.82, so b is equals to 1.91 per centimeter. Mu is given as 1 into 10 to the power minus 26 kilogram. Velocity of light is taken in CGS unit as c is equals to 3 into 10 to the power 10 centimeters per second. Planck's constant is h 6.626 10 to the power minus 34 joule second. For the solution, let us go for part 1. We'll solve this numerical in two parts. You can, after getting practice, you can solve it in one step. So part 1 is calculating moment of inertia by using a rotational constant value, which is obtained from spectrum. The value of b is equals to h upon 8 pi square IC. So we know that b is equals to h upon 8 pi square IC, so I is equals to h upon 8 pi square BC. We can put the values of h, pi, b and c and calculate R. So after putting the values of h as 6.626 10 to the power minus 34 and value of pi is 3.14 square and multiplied by 1.91, value of c is 3 into 10 to the power 10 kilograms per meter square. If you carefully note that the value of b and value of c are in CGS unit, but the remaining all values are in SI units. This is because the value of c is centimeter per second and the value of b, that is rotational constant, is per centimeter. So they cancel each other and all units are later becomes SI units. So after calculating this, we get I is equals to 1.555637 into 10 to the power minus 46 kilogram meter square. Thus we found out the moment of inertia. Now we can find, by using value of moment of inertia, value of bond distance R0. So let us go for step 2. So in the part 2, we'll calculate bond length of the molecule using moment of inertia. We have I is equals to mu R0 square. Thus R0 square is equals to I by mu, and taking root, R0 is equals to I divided by mu, root of I divided by mu. Put the value of I, put the value of mu, simplify, calculate, you can find value of R0. We put the value of I is 1.555637 into 10 to the power minus 46 divided by value of mu as 1.0 into 10 to the power minus 26. This minus 26 will go up and will become plus 10 to the power plus 26, and that becomes 10 to the power 20 plus 20 minus 20. And thus after taking root, R0 is equals to 1.2472517 into 10 to the power minus 10 meters, and thus finally converting that meter to angstrom unit, you will find R0 is equals to 1.2472517 angstrom unit. Thus we found out the value of bond length of CN molecule as R0 is equals to 1.2472517 angstrom unit. Thank you for watching. Subscribe my channel. Thanks.